Okay, Assalamualaikum and hello. So, uh, this is a new topic. Okay, power measurement in three-phase circuit. Okay, so this one falls under chapter 1. Okay, in the CI it's not available, but actually this one is important topic. So you have to learn about it. Okay, so how to measure three-phase circuit? Remember that I said you have to measure. Okay, so you have to measure. Let me move this up. You have to measure the phase, okay, to determine the power, total power. Okay, so for balanced load, you have just multiply by 3. Okay, so you just multiply by 3. Okay, for unbalanced load, okay, you have to calculate 1 by 1. Okay, but how about measurement? Okay, this one is calculation. Okay, the calculation is quite long. So how you want to use a measurement wattmeter, how to use wattmeter to measure the power for three-phase system. Okay, so remember that I said you have star and delta. Okay, star has 4 wire and 3 wire. Okay, wait, let me check recording. Okay, so this one and this one. Okay, this one of course 3 wire, delta always 3 wire. So because of the measurement of the power is done through the phase, okay, and not the line, so you can measure the power easily with 4 wire because you have neutral wire here. So you can see here you have 3 watt power watt meter. Okay, means that the meter that measure power. So you just connect A to neutral, B to neutral, C to neutral. So you can get the power for 3 phase. Okay, you can get the power for 3 phase. Okay, but how about 3 wire like delta and star 3 wire? Okay, so for this case, these two, okay, you cannot do that. Okay, you cannot use 3 phase wire because you don't have the neutral wire to connect to. Okay, there is no neutral wire here, so you cannot use 3 watt meter. So to overcome this problem, you have to use 2 watt meter method. So what is 2 watt meter method? Is basically you only use 2 watt meter instead of 3. And instead of connecting the negative side, okay, negative side of the watt meter to the neutral line, you just connect it to B. Okay, you can see here it goes to B. Okay, you can see here. Okay, this one I already show you. Okay, 3 wire star or delta, star 3 wire or delta, you have to use 2 watt meter method. Okay, only star 4 wire can be measured using 3 watt meter method. Okay, which is much more direct to the point. But for this case, you cannot use 3 watt meter. Okay, you have to use 2 watt meter. Okay, so how to do this? Okay, this one is the standard one. Okay, you have a current here, line current. You have phase current, line current or phase current. Okay, and then you connect it to the neutral part. Okay, and then you can calculate the power because power is just I is multiplied by. Okay, I is, let me show you, maybe it's easier if I show you this. Okay, remember delta, star connection, star 4 wire. Okay, so P is equals to V phase, I phase. So I phase and I line is the same. Okay, for star connection, right? So I phase. Okay, so for this case, because this one is different, we phase is not equals to V line, but for calculating this we use V phase. So V phase is from A to N. Okay, VAN, VBN, and VCN. So that's why we use 3 wattmeter. Okay, to find the power for each phase, and then we just add it up. Okay, that is 3 wattmeter method. Okay, this one is the unique one. Okay, for delta connection and as well as the star connection with 3 wire. Okay, so for these two cases you have to use a 2 wattmeter method. So how to calculate this? Okay, so basically, how to calculate this is basically you just P total is just equals to PAB plus PCB. Okay, so you have to focus here. Okay, you see here. Okay, usually we use EAB plus PBC and plus PCA. Okay, but for this case it is flip. Okay, this one is 3 wattmeter method. Okay, this one is 2 wattmeter method. So you have to flip this connection instead of using B to C, C to B. Okay, so how to do this? Okay, so maybe this one is the example. Let me check first. Yes, reading the 2 wattmeter method to calculate the total power. Okay, let me pause it first. Okay, my PC is hanging. Okay, I will reset it. Okay. Okay, so let us start. Okay, a balanced Y connected. Okay, so 3 wire. Okay, make sure you know the difference between star 3 wire and star 4 wire. Okay, so okay, this one Y connected load is supplied from a symmetrical 3-phase 440 volt 50 Hz system. So you can see here V line is 440 volt. Okay, positive sequence. Okay, the current for each phase is 20 A. So the current in each phases. So this one is I line is equals to I phase. Remember, star connected, I line is equal to I phase is 20 ampere. Okay, so this one is a balanced load, but also for 2 wattmeter method, it can be used for balanced and unbalanced load. Okay, so you can see here I line is equal to I phase. Okay, and the voltage is and V phase, okay, is lag behind 40 degree. Okay, lag behind 40 degree. So let me remove this first. Means that so 20 ampere, but for this case it can say that IA is equals to 20, so current is lagging. Lagging means that negative 40 degree. Okay, so IA is 40 degree because we want to use VAN as reference. So means that VAN is equals to, okay, you have to convert this VL divided by 40 angle 0. Okay, because we want to use this as a reference. Sorry, this is not 40, VL. Okay, remember VL equals to square root of 3 V phase. Okay, so VAN is equals to, let me delete this, divided by square root of 3 angle 0 because of the reference point. So 440 divided by square root 3 angle 0 degree equals to 440 divided by square root 3 is 254.034 angle 0 degree. Okay, so this is the first phase voltage. Okay, so next is the VBN. Okay, so 205.403 angle 0 degree. Okay. So for 0.03 angle 120 degree negative. Okay, so this is a, because this is a balance load. Okay, you can see here balance load. Okay, you can apply this law. Okay, you can just directly change this. VCN is equals to 205.403 120. Okay, this is applied for balance load only. Okay, you can see here IA is the same. Okay, the angle is also the same. But if it is not a balance load, remember you have to do a mesh analysis. Okay, recall back. Where is it? Mesh analysis. Okay. Okay, you have to, okay, this one. Okay, remember you have to do a mesh analysis. Okay, so recall back, if you are using an unbalanced load, you have to use this one. Okay, so you have the, let me go to the question back. Okay, this is the phase voltage. How about the load parameter? So the load parameter, is, so Z is ZA equals to ZB equals to ZC because of the current, remember. So equals to we just choose one. Okay, I suggest you use AN because it is a reference, easier for you to calculate. Divided by IA. Okay, so VN is 254.03. Okay, angle 0 degree divided by 20 angle 40 degree. So you get, so don't forget negative. Okay, divided by 20 negative 40. So you get the current is 12.70. Okay, angle 40 degree. So you get the parameter is this one. Okay, okay, remember for the load, I suggest you use the rectangular form. Okay, so don't use this, use 9.73 plus J 8.16. Okay, so ohm. So you find the load parameter. So the total power P is equals to, because this is balance load, remember balance load, you can just 3 phase AN I AN cos theta. Okay, so 3,254.03. Okay, I is the 20. Okay, don't include the angle. Okay, cos, okay, the angle you place it here, so 0 minus 40. Okay, minus 40. Okay, so 3 multiplied by 254.03 0.03 multiplied by 20 cos 40. So you get the total power is 11675.8, okay, 0.91. Okay. And how about the reading of 2 wattmeter method? Okay. So let me adjust this. So if you use 2 wattmeter method, okay, it should have the same answer is this. Okay. So 2 wattmeter method, okay, P is equals to V. So you have to find PAB. Okay. So PAB is equals to VAB I A. Okay. So cos theta AB VAB minus theta IA. Okay. So for this case, VAB is 440. IA is 20. Okay. Cos theta B, remember V line is equals to V phase multiplied by square root of 3, okay, angle 30 degree. So you have, because this is 0 degree, okay, 0 degree, this one 30, you get 30 minus negative 40, you get 440 multiplied by 20 cos 70, 3009.77, okay, and then PCB. Okay, so PCB is basically VCB IC cos theta VCB minus theta IA. So theta VCB, okay, so you have to do a loop here. Okay, so let me pause this a bit. Okay, so IC you already obtained it here. Where is IC? Okay. Oh, I don't show it. Let me move this. Okay. So IC is basically 20 ampere angle 120 minus 40. Okay. So 20 angle 80. Okay. Okay, remember this is lagging 40 degree. So IC 120 minus 40 degree. Okay. So VC is VCB, you don't know it, so you can calculate it using mesh. Okay, so this one is VCB CB. Okay, and then you have, this is B, this is C, and then this one you have resist at B. Okay, this one is VBN. This one is VCN. Okay, so if you do a loop here, VCB is equals to, okay, this one positive, negative, positive. Okay, so VBN minus VCN. So VBN is 2.5 something. 2.5. Let me check back. Okay, so 254.03. Okay, and the angle is negative 120 plus 254.03. Okay, angle is 120. Okay, so calculate back. So sorry, this one is negative. This one is negative. So you get 439.99, angle negative 90. Okay, so basically this one is 440, angle 90 degree. Okay, so use this formula back. This one is 440 angle 90. So this one is 440 20. Okay, cos theta. Okay, theta v is 90 minus 80. Okay. Okay, so 866.31. So you have, okay, you have PAB and PCB. Okay, so now the P total is equals to, because of the 2 wattmeter method, PAB plus PCB is equals to 3009.77 plus 8666.31. So if I use my calculator, let me pause it. So you get 11676.08 watt. So if you compare this with the normal calculation, this is the normal one and this is the 2 watt method. Okay, you get almost the same answer. Okay, there is slight difference because we take a different decimal point. Okay, but should be close. Okay, so make sure you know how to calculate it normally and how to calculate using 2 wattmeter method. Okay, if you use wattmeter, it should be this approach. Okay, so this is how to calculate for delta connection. Star connection. So after this, I will show you how to do it in the delta connection. Okay. Let me split the video.